Hi, everybody, and welcome to our latest live event. Today, we're going to introduce planetary imaging to Telescope Live. Now, if you're new and you're joining our event for the first time, a quick introduction. My name is Marco Rocchetto, and I'm the founder of Telescope Live. Telescope Live is a platform for astrophotography, giving you access to a network of robotic telescopes around the world in both the northern and southern hemisphere, and it gives you all the tool both in terms of introduction to astrophotography and the data, the best quality data to produce fantastic astrophotography pictures. So if you've never tried Telescope Live, you can do it now for free. There is a 30 days free trial at telescope.live, and you can join the world of astrophotography with us. Today we're introducing planetary imaging. Up until today, our users were able to observe galaxies, nebulae, and stars, but were not able to observe solar system planets. And this is because planetary imaging is slightly different from deep sky observations. It requires different instrumentation, different equipment, different observing techniques. We are finally able to offer it to you today, thanks to specific equipment installed at the 1 meter telescope in Chile. And to introduce this new feature, this new observing modality, we have the honor to have with us today Mr. Damian Peach. Damian is widely considered one of the best astrophotographers in the world, specifically for planetary images. His images have appeared in countless books and magazines, and he also appeared in several television programs within the UK to promote astronomy and astrophotography. So, Damian, thank you very much for being with us today. I leave the floor to you to talk about planetary imaging and introduce this new feature. Thank you.
Okay, thank you. Thank you very much, Marco. Okay, so today I'm going to be giving a short presentation on planetary imaging and just giving potential users an introduction to planetary imaging with Telescope Live, just to give you an idea of how this will work and some of the technicalities involved and the kind of results that can be obtained using this remote telescope. So just moving straight on into the presentation. Now, obviously, with deep sky imaging, which involves imaging galaxies, nebulae, etc., it's this has now been very well automated in terms of remote imaging, and it's possible to take some really good data using completely automated telescopes. But unfortunately, when it comes to planetary imaging, there are certain factors that at present make it very, very difficult to automate the process in the same way that has been done with deep sky astrophotography. So the way in which planetary imaging is offered is somewhat different in that it can't be completely automated as you would have with deep sky, where you simply schedule a session and the telescope will collect the data and then you'll download it later on. So, as I mentioned, there are various differences with deep sky and planetary imaging, and I just want to kind of go over just a few of them, for those that aren't entirely familiar. Now, obviously, deep sky involves long exposure astrophotography of faint celestial objects such as galaxies and nebulae. And as I mentioned, these days with remote telescopes, it can be fully automated, and the data is taken with still frame cooled CCD cameras. Now, with planetary imaging, it's rather different in that we're imaging at high focal lengths. We're using very short exposure, fast video cameras. So we're taking many, many images per second to try and beat the atmospheric turbulence that we have to deal with, because we're looking through Earth's atmosphere at celestial targets. And when you're imaging at high focal lengths, this has the turbulence in our atmosphere has a major effect on the quality of the images that you can get from ground-based telescopes. And you can also see that I've noted there that the data must be taken manually. And that's primarily because focusing with planetary imaging can be very, very tricky at high focal lengths. So you can see there are some fairly obvious differences with deep sky and planetary imaging. Now, as I've mentioned, with planetary imaging, we're using high-speed video imaging cameras to shoot images at anything, depending upon the target, from 20 up to 150 images per second. And we're also imaging at high focal length. So with deep sky and nebulae, you're typically imaging at very low focal lengths. With planets, because they subtend a very small angular size in the night sky, it means we need to operate at a high focal length to see any details on them. In terms of sky darkness, it's not really important because, typically the planets are unaffected by light pollution, and indeed that's not really a factor in Chile anyway. But the kind of big factor that is really vital to how good data will be is the astronomical seeing. And as I mentioned, that is the turbulence that occurs within the Earth's atmosphere. And a really stable, calm atmosphere is absolutely paramount to getting sharp quality data and detailed images of planetary targets. The data you take from these cameras, it comes off in a video format, typically SER or AVI, and these files can be extremely large, several gigabytes in size typically. And what we have to do is reduce that data down into raw stacked files. So typically we're stacking maybe 1,000 to 2,000 frames out of a video sequence to construct a raw image, which we can then process later on in other software. So with Telescope Live, there are two options available. So perhaps the most exciting one is to actually book a live planetary imaging session where you will actually log on to the telescope via remote connection yourself, and you'll be able to conduct a live planetary imaging session logged on via a remote connection, such as with TeamViewer, for example. And you'll be able to focus, change filters, and basically do the entire process yourself under my own supervision. So I'm on hand during the session to assist should there be any problems or difficulties. The other option offered is pro datasets, where Telescope Live takes datasets and you can then download those. And that's probably the best option for those unfamiliar with the process of planetary imaging. And it kind of should be noted that actually doing a live planetary imaging session does really require that you have some at least basic familiarity with the process of planetary imaging. Now, the telescope itself that is used for planetary imaging is an ASA 100 centimeter f8 Ritchie-Chrétien located in Chile. The camera attached for planetary imaging at present, although this is possible to change this fairly easily, is a ZWO ASI 174mm mono imaging camera. The operational image scale is around 0.06 arc seconds per pixel. So as I say, we're operating at quite a high focal length, and it's actually operating at f16. So there's a 2 times Barlow in the imaging train to get higher focal length. And you can also see there, we've got a range of different filters, such as LRGB. There are a couple of near infrared filters. We also have a methane band imaging filter, which is very useful for taking images of the gas giants, Jupiter and Saturn. And we also have a UV filter, which is particularly useful for imaging the cloud features of Venus. So just to talk a bit more about the live sessions, and you can see here, this is a live screenshot of a session on Mars. So that's Mars live in a near infrared filter, and you can see various features on the planet there, such as Solus Lacus and the South Polar Cap. And the live session is, as I mentioned, a connection via TeamViewer, which is a remote access program that you can download for free. And as I say, you can observe an image in real time. And the camera is operated via the fire capture imaging program, and this is widely used throughout the astronomical community for planetary imaging. So, you know, many people do have familiarity with how to use it, and it's fairly easy to get used to using as well. So the use of it's fairly straightforward. The filter change, so when the filters change, if you're imaging different filters and you want to change from one to the other, it will automatically change to the focus position for each filter. And you can indeed manually focus using the fire capture focus control. So if you want to adjust the focus at any time, it can be done live using the fire capture control. Now, collecting the data, you can see I've noticed some various points here. And as I said, the telescope has a variety of different filters. But when you're using this telescope in particular, because it's such a large aperture, typically the sharpest results are always in the near IR filters. And as I say, these generally always produce the most detailed imagery of planetary targets. I typically pre-focus the various filters on the telescope before the session begins, just to help things run more smoothly. But as I mentioned earlier, you can actually adjust the focus if needed. Now, there are different techniques that you require for different targets to obtain optimal results, and I'll talk a little bit more about that in a moment. And there are various video tutorials available that can offer much more in-depth guidance than is possible in a simple presentation such as this. And another kind of fun thing you can do with a live session is you can actually image more than one target in the session if it's available. So, for example, there can be a session perhaps where you want to spend half the session imaging Jupiter and then half on Saturn, as both planets are fairly close together in the night sky at present. So you could actually spend half the session on one and half on the other if you desired. I'm also on hand, as I've mentioned, throughout the imaging sessions to assist and advise if required. And there is a live chat feature in TeamViewer where you can talk fairly easily, and it works really well. And typically during planetary imaging session, you're going to be looking at collecting probably 100 gigabytes of data, particularly if the conditions are good. It can end up generating quite a significant amount of data. And obviously that needs to be reduced later on during the processing stage. So typically you'll log on to process the data yourself via a remote connection later on after the session is finished. And just to give you a general overview of how planetary video data is processed. So the first stage is loading the video files into a program called AutoStacker, which is loaded onto the remote PC. And you use that to then reduce the video data into raw images. And typically you'll stack maybe 1,000 to 2,000 frames from any video sequence to create a raw planetary image. And you'll do this with each sequence, and you can then download the raw video files to your local PC for further processing. And the next stage in processing is to sharpen those raw stacked image files which you've downloaded. And you can see here an image of Saturn which has been sharpened using the wavelet controls in Registacks. And this is typically the most popular way of sharpening planetary data. And you can see there the Cassini division nicely visible in the ring system. And this is kind of really the fun part, is this is where you really get to see what you've managed to capture during the imaging session. So the next stage on from that is typically the use of WinJupos for planetary image derotation. And this is a particularly useful process when it comes to imaging targets such as Jupiter and Saturn, as it allows you to stack a lot more data into an image than you would otherwise be able to by conventional methods. So typically with Jupiter, you'd be limited to 2 to 3 minutes to capture all the data for an image. With Saturn, around 5 minutes. With a program like this, it allows you to open the window up for a single image to around between 20 to 40 minutes. So it really allows a massive improvement in the overall quality of the final image to be realized using the WinJupos program. And the next stage on from that is to compile the images into a color image. So typically you may have taken some RGB image data during your session. You'll want to create a color image, and you'll use a program such as Photoshop to compile the RGB channels into a final color image. And that is kind of the basic process that's involved with planetary image processing. Now, just to move on to another factor that I want to talk a bit more about when it comes to planetary imaging, and this is an extremely important issue when it comes to the quality of the image data, and that is a phenomenon known as astronomical seeing. And you can see there I've just basically noted what we mean when we say astronomical seeing. And it's basically the degradation of the quality of the image due to turbulence within an Earth's atmosphere. And obviously that can vary from site to site and from night to night. But planetary imaging is especially susceptible to the effects because of the high focal length we're working at. And as I mentioned, it's also perhaps the #1 factor that will define how good your resulting data will be. And as I mentioned, it varies from night to night, even at the best locations, such as in Chile, for example, where you're imaging from a remote mountaintop. Even there, the seeing varies from one night to another. So some nights can be really superb, other nights not so good. And I'll just talk a bit more in a moment about a forecast tool that is really well worth looking at when you're looking to schedule a planetary session. So if you go to the windy.com weather forecasting tool, you can actually look at the jet stream conditions over Chile, and the high altitude jet stream winds around 10 to 11 kilometers above the surface have a major impact on the quality of the seeing across this area of the world. And you can see here in this chart that I captured from the site that shows the wind speeds up at that altitude. And what you're looking for is fairly low wind speeds. So you can see there I've clicked on roughly where the observatory is located, and the wind speeds up at the jet stream level there around 40 knots. And typically you're looking for low wind speeds. So anything below 80 knots has a chance of producing good seeing. Now, those brightly colored yellow areas you see there are areas where the wind speed is very high. And typically when it's over 100 knots, good seeing conditions are unlikely to occur over the observatory. So it's well worth looking at this tool maybe a few days ahead from when you want to book a session, to give you an idea of what kind of jet stream conditions will be prevailing over the region during the time you want to schedule your session. So it's a really easy kind of site to use. As I say, just visit windy.com and you can view the conditions over Chile, and it'll give you an idea of what the jet stream is doing over that region. And just to give you a real example from the telescope itself, you can see here two images of Jupiter, the one at left taken in poor to average seeing conditions, and the one at right taken in good to excellent seeing conditions. And obviously you can see quite a considerable difference in the number of small features visible within Jupiter's atmosphere between those two nights. So the only difference between those two images is the stability of the Earth's atmosphere. So it just goes to illustrate how important it is to have good seeing to get sharp images. And just a second result, again, showing you the difference between good seeing and poor seeing. And again, you can see quite a considerable difference between the features visible on Mars between those two nights. And I'm just going to show a few results obtained with the telescope over recent times. And obviously there are lots of targets available to image. So the moon is a fantastic target. And if you get a good night, you can see features down to around 200 to 300 meters in size. So you can obtain very high resolution views of lunar features. And here we can see an image of Plato taken during a night of good seeing. Mercury can also be imaged during favorable elongations, and the most favorable elongations of Mercury occur in the southern hemisphere. So it can be quite fun to schedule a session to do that. And here you can see an image of Mercury captured with the telescope during a morning elongation in April 2019, and with various features visible on its small disk. Venus is also a great target, and of course we have a UV filter fitted to the telescope, and you can see lots of features within the Venusian atmosphere using UV filters, and it's a fairly easy object to image due to its extremely high brightness. And it's currently, at present, it's moving back into the evening sky slowly at the moment. Saturn, of course, is well placed now in the dawn sky, and is slowly approaching opposition this July. And you can see here a view taken under good seeing with the telescope back in 2017. And when you get good seeing, Saturn is obviously a really impressive object to image. And you can see lots of features within the rings and atmosphere. And the rings are, of course, slowly closing up now from year to year. And this is the first year we're able to again see the southern hemisphere peaking above the ring system, which is kind of a distinctly blue color at the moment. So that's quite a fun thing to observe. And of course, Jupiter is headed towards an extremely favorable opposition this August for the southern hemisphere. It's one of what's called its perihelic oppositions, where its angular size will appear particularly large at opposition. So it will be near almost 50 arc seconds during its opposition in August. And if, during a night of good seeing, will show a tremendous amount of detail, as you can see here during this image captured with the telescope back in 2018. Of course, Mars just went through a very favorable opposition last year. Unfortunately, it won't come to opposition again until 2022. But you can see here a view captured with the telescope during its close approach last year in 2020. You can also image the distant ice giant planets using the telescope, and here an image of Uranus captured with a near IR filter during a night of good seeing. And of course, you can see some features, quite distinct features on the small disk of Uranus when seeing is good in the near infrared filters. And there you can see the bright polar cap and thin equatorial band visible on the planet. So if you're interested in learning more about image processing, and obviously it's impossible to cover that in detail in one presentation, you can visit my tutorial website, which contains over 110 tutorial videos and data sets that you can practice techniques on, and it will really help you get up to speed with planetary image processing. So just to summarize and conclude this presentation, just to note a few points, live sessions are really only suitable for those with some experience in planetary imaging. If you don't have at least some kind of rudimentary experience, you may find it a little bit difficult to begin with. When you're booking a session, just make sure the objects that you're booking are actually visible in the night sky, because obviously the planets aren't visible 365 days a year. As their motions across the sky and our motion around the sun carries them into conjunction with the sun every year. So that's one thing to keep in mind. So the period of time they're available are often limited. As I've already mentioned, astronomical seeing will be the primary factor in how good your data quality will be. And of course, check the jet stream forecast before booking any planetary sessions. And of course, if you any questions or comments, just ask for advice. You could email me. There are other people available as well, various groups online. So there's a big community out there that can offer assistance. So that pretty much concludes this presentation on planetary imaging, and I'll look forward to doing some sessions with some of you soon.
Fantastic, Damian. Thank you very much. And we're also very happy to have you here at Telescope Live as one of our tutors for planetary imaging. So I would like to show you now how you can actually book your live sessions on the website. and how you can access the pro data sets. So I'll share my screen and I'll show you. Here we are. Okay, can you see? Yes. Okay. So this is the Telescope Live dashboard after you log in, and planetary imaging is available for silver and gold members as pro datasets and as advanced requests. So let me start with the pro datasets. We've just released 2 for today, but we'll release more in the near future. So you will see here Jupiter as a standard pro dataset and Mars as a premium pro dataset. Premium pro datasets are only available for gold members. And these images are image stocks that have been pre-processed by Damian and have been acquired originally by Damian. So pro datasets will basically be curated by him, and the image stacks will be provided. And you can download them from here. The total size, as you can see here, it's not much. It's around 10 to 20 megabytes. And inside these sets, you will find the individual TIFF images acquired in the individual filters and pre-stacked for you. So if you're new to planetary imaging, this is a great way to kickstart and get familiar with the technique. But if you want to get your hands a bit more dirty and you want to book a live session, then you need to navigate to Advanced Requests, New Request, and here you select Solar System Planets, the third one here. This is the new option. You press Next Step, and you need to schedule your session. So the scheduling calendar will help you do that. And in here, you'll have a timeline, basically day and time. The time is in UTC, Universal Time. You can scroll here at the bottom and you will see the astronomical night appearing. So the astronomical night is from 11 p.m. UTC till 9:15 UTC. And here you have the weather. So this is the weather forecast for the next few days. And you see also the observability of the planets. So you've got Saturn and Jupiter here. And finally here, you've got the schedule for the 1 meter telescope. Now, you need to book at least 1 day in advance. So 24th is too early. You need to go to the right a little bit. And the first available time is on the 25th. And here you see the green shaded area. It's where you can drag and drop your observing session. So here at the top, you've got the observing session that you can drop at a given time. So you need, of course, to make sure that the planets are visible, but the system will help you because the green shaded area here will only be in correspondence of a planet being visible. And as Damian said, you can observe both. So if you are quick enough in managing your session, you know, with Saturn and Jupiter up in the sky at the same time, you can jump from one to the other. And make sure, obviously, that the sky should be clear. When it's not clear or cloudy, you have orange or red icons. Otherwise, it's green. And you should also check the jet stream forecasts. As Damian said, that's one of the most important things to base as a proxy for the seeing. And we have a help page. You can navigate to our help center. The planetary imaging session has a new seeing and jet stream forecast. It's already pinpointed to our observatory. And you, of course, need to move the bar here at the bottom in correspondence of the time you want to book, and you can check the wind speed down. 64 knots is relatively good. Anything above 80, you said, Damian, I guess, shouldn't be booked because the seeing is likely to be bad. Yeah. So right. Once you've selected your time, you press next step, and you can confirm. Now the price is fixed, and there is no moon discount because the moon doesn't really affect planetary observations, and it's fixed at 220 credits. Or if you're in gold, you will get a 20% discount, which brings the price down to 176 credits. So if you do want to submit a planetary session, it's quite recommended to upgrade to gold, because the discount you will get more than offsets the increasing cost in your in the gold plan. So what happens next? You press confirm. You will receive an email with all the details straight away about your session. And what happens is that Damian will contact you the day before your session to confirm if the session will go ahead or not. And this is also based on seeing and weather forecasts. If the weather is good and is predicted to be good, then you will receive 1 hour before the session the details to TeamViewer access to connect remotely to the machine that controls the telescope. You will, of course, then need to connect to the telescope machine. Damian showed you how that works, and I strongly recommend you, if you do join one of these live sessions, to go to our tutorial section. There is a new live sessions of planetary imaging from Damian, and you have two. Part one shows you the software used, fire capture, used to control the camera. And this is what happens basically during your live session. Once the live session ends, and each live session lasts 1 hour, Damian will be with you. If you need anything, he'll be there to help you and assist you. Once the session is finished, the data is transferred to another machine. Now, Damian mentioned this. The amount of data that is generated during such live sessions is too big to be transferred to your computer straight away. We're talking about hundreds of gigabytes. So these sets are transferred to another computer within the observatory, and you will have access to that computer for a day or two to post-process your images and create the image stacks. Now, the image stacks is what you create with AutoStackert, and then you can download the images on your computer and follow up with the post-processing to then create a color picture. Now, the data you get through the Pro data sets are basically the image stacks that are generated with AutoStackert. And this is what Damian will curate when we generate new Pro data sets. Last thing, as Damian said, he's got a wide variety of tutorials in his website. We'll share the link with you. So do join one of his membership levels to get access to 100 and over tutorials. Each planet has its own techniques, so it's not that easy. But Damian provides all the material to generate stunning astrophotography pictures of planets. All right, so this is it. You can start using it from today. You can submit your advanced request for planetary imaging from today, and you can start to download the Pro datasets starting from now. We'll get a few more in the next few days. And so thank you very much for listening and joining. Thank you, Damian, again for joining. We'd like to dedicate the last 5 to 10 minutes of the session today for questions and answers. So we can start maybe with something from the chat, which you see here. So I'll stop my screen share. If we find it, here we are. So somebody's asking about the 30 degrees horizon that we currently have on our telescopes, and we will try to lower it. Damian, you might know better than me what's the minimum altitude on the 1 meter.
Yeah, with planets, I've imaged down to 20 degrees, and you can image down to 20 degrees altitude with it. Some of the Mercury images were taken that low down. However, I would say that it's always best to try and book a session when a planet is as high above the horizon as possible. So, you know, with Jupiter and Saturn at the moment, we have them both from the southern hemisphere. They both pass close to the zenith, so it's not really an issue. But with some targets, it can be. But typically, yeah, you can go down to like 20, 25 degrees.
Okay, Anurag is asking if we can image planetary nebulae using lucky imaging with the 1 meter telescope with slightly longer exposures. And I'd say, I mean, Damian, you might elaborate on that.
Yeah. I've imaged the Eta Carinae, or the very core of the Eta Carinae nebulae, using that technique with actually a really good result. And I would say that it's probably only possible on the very brightest objects because of the high focal length
and the short exposure time as well.
Yeah,
so it's very bright, maybe.
It is tricky and quite time consuming to get a good result.
And Conrad is asking if or why we're using shark cap and not instead of fire cap to capture the.
So the telescope is using the fire capture program, and it's primarily using the fire capture program as that one has it's probably the most widely used by experienced planetary observers. I mean, it's the program I've been using fire capture pretty much since its inception. And it's a really good piece of software for planetary camera control. So that was the software we decided to go with.
Okay, so if I can't see any other question here. So if nobody has any other question, we'll end the event here.
Okay.
Of course, the video will be available on YouTube if you missed it or if you want to watch it again. So thank you everybody for joining. Thank you, Damian, for joining and presenting planetary imaging, and of course for being our future tutor for planetary imaging. So we'll be looking for you in the next live sessions, and have a good day. Bye.